when they first call us, their engineering leaders, product leaders are saying, we're finally ready to get serious about evals. Tell me more. And they basically say, we don't know what's going wrong in production. The most common advice we hear from people that have made it to scale is we wished we'd started working on evaluation earlier. And at the far extreme of that, the most mature teams, you talk to folks at Google or at OpenAI, like start with your evals. So most mature teams have learned you begin by defining what the shape of this system should look like. What are the failure scenarios? What's a positive case look like? Define that up front. And then you're basically doing all your prompt engineering and agent orchestration, like hill climbing toward that metric. The breakthrough in quality that so many teams have experienced has come from people just getting close to the data, sometimes thousands of rows.
Welcome to ODSC's AIX podcast, your gateway to the latest in AI and data science. Whether you're an aspiring data scientist or a seasoned AI professional, we bring you insights from the best minds in the field, shaping the future of AI. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Seamus McGovern, the founder of ODSC, will be your host today.
Welcome back to the ODSC podcast. In this episode, we'll dive deep into one of the most pressing challenges in AI today. How do you reliably evaluate and operate LLM-powered and agentic AI systems in the real world? Our guest is Cairns, co-founder and CEO of Freeplay, a platform designed to help teams build production-ready AI systems, complete with evaluation, observability, and human-in-the-loop workflows. We explore the real shape of the AI maturity curve, what it takes to move from vibe prompting to scalable infrastructure. Ian shares how companies are wrestling with offline versus online evaluation, when to optimize prompts versus switch models, and why even sophisticated teams are still flying blind without the right telemetry and eval systems in place. So if you care about building applied AI that actually works in production, this episode is definitely for you. Ian, welcome to the podcast.
Thanks for having me on, Seamus. Good to see you.
Yeah, we met about a month ago at a conference, and I was very interested in Freeplay and what you guys are doing. But Ian, before we get into the details of evaluation frameworks and all that good stuff, could you give me a quick background, maybe tell us about your career, some key moments, and the origin story of Freeplay?
Yeah, awesome. It's good to meet you all. I'm Ian Cairns. Like Seamus said, started Freeplay fall of 2022. How did this come about? My co-founder, Eric, Ryan, and I were at a startup called GNIP. We built the pipes for the social media monitoring and analytics ecosystem. And we got acquired by Twitter back in 2014. We ended up spending 7 years at Twitter and had a really great decade of working together. We got to take that GNIP business from $40 million rough, ARR run rate at acquisition to almost 400 million ARR by the time we left. Got to be part of scaling the Twitter developer platform. I ended up as head of product for developer platform at Twitter, which included the public APIs as well as our enterprise data licensing business, which is where all that revenue came from. A lot of people don't know Twitter even had that business, but that was like licensing the fire hose to big companies and all the data products around it. And then Eric led engineering. We had a good time. Historically, I've always worked on mostly developer products, but as a product person, I was early on the team that ended up launching Mapbox. That company's grown and done well over the years. Got to spend some time in the Obama administration early on the first term, helping with some API projects and open data projects when they're getting those off the ground. So I've always been at this intersection of how you bring good developer products to life that people can really build around. And summer of 2022, Eric and I were both other startups. We were talking about what did we want to do next together? And we wanted to come back together. We wanted to start a company we were going to work on. Eric gets the credit one weekend. We'd known the OpenAI team. They'd been interested in the fire hose, and we were at Twitter. DaVinci was just starting to take off, and the hype was building on the developer forums. It's like, hey, we should spend some time hacking on the GPT-3 API. This is August, September 2022, just ahead of what was going on with ChatGPT. We got really excited about the space. We'd seen the set of needs people were going to have around moving from, at that time, the conversation was AI was mostly still a research thing. It's finally moving to an application thing with generative AI, at least. We knew that production teams were going to have a whole set of needs there. We'd run those teams for years. We knew that there was going to be a whole transition in how you build software, how you test it, how you get it to work at scale reliably. And so, we started working on this full time in December of 2022.
Yeah. That's pretty cool, Ian. And you've got a very impressive background. You were director of product, developer platform for 6 years, and then you were a VP of product and design at First Base. And now Freeplay, your CEO and co-founder. So I guess the first question, what makes Freeplay different from other platforms in the AI landscape?
Yeah, I mean, I started talking about that a little bit, but I'll go deeper. I think that's one of the main things. From day one, our backgrounds are not ML. We had teams we worked with at Twitter that were doing ML tech. We were not from the ML side ourselves. We were coming at this problem early on, thinking about how do you help the production teams that have been building customer facing features for the last 10, 20 years, pivot from traditional web app and distributed systems and mobile app techniques and approaches to working with generative AI. For all those folks that had not been building in this space, we knew there was going to be a big change. From day one, we were really focused on how do we solve the problem of the product development organization that ultimately it's like trying to figure out how do we move the metrics up into the right? How do we get more people using our stuff, paying us more? That's the end goal. We knew that in that world, you're not really going to be successful if you just have some piece of functionality here. You don't just need evals. You don't just need observability. You don't just need data labeling or experimentation tools. Like those teams are really trying to figure out how do we run these systems? How do we close the feedback loop from discovering that something's not working like we want it to making it work better? So we tackled that from day one. And another thing we saw early on was just how many domain experts we've seen, MDs, accountants, financial analysts, all sorts of people from outside the engineering and product organization, how many of those folks were getting pulled in, even back in early 2023, to learn prompt engineering techniques, be critical parts of data QA. We built Freeplay from day one in a mindset that this product should work in a first-class way for everybody involved in the process, even if you don't live in an IDE, even if you don't live in a Python notebook all day long. If you need to work in a UI and make sense of this data and test out new things, or even write an eval, we wanted to make sure that was really a first-class experience. Today, what that looks like is we have dozens of people in a given team working together, engineers launching and debugging things and connecting with our SDKs for observability, for evaluation, for prompt and model experimentation. And then we have a group of non-engineering domain experts, product managers, designers working on not just prompt engineering tweak in a playground, or can I look at some logs and review data, but in Freeplay, you can also like build and launch evaluations, test those evaluations and make sure that they align to human expectations, run multi-variant A/B/N offline eval tests at scale, all through a web UI without having to touch code or a notebook. So what it's allowed is our customers who've got this whole organization working together in Freeplay to build and ship generative AI products.
Thanks, Ian. That gives us a great sense of where Freeplay is positioned, especially in helping teams go beyond demos and getting code running. And I love this idea of the DIY AI. And as you said, people getting pulled into doing prompt engineering. So how can these non-machine learning engineers and domain experts work with AI without having to touch code? We often hear about this AI maturity curve within organizations, right? I think I've heard you use the phrase vibe prompting, which is pretty cool, because you want to get from prototype to something that's reliable in production. But as we know, in practice, that transition isn't linear, especially for some of those domain experts you talked about, those workflows, evaluations, team structure. So when you work with an organization, in your experience, what does the AI maturity curve actually look like in practice? What are some of the key milestones you see that teams go through? What tends to separate teams that make it to a successful product deployment versus those who stall out?
Yeah, it's an interesting question. I'll share a few things we've seen from experience, tell a couple of stories maybe. One part of our world, and this is like part of the answer, probably 95% of the people we talk to are already in production, often like 3, 6, 12 months before we end up talking to them. I think that in and of itself is part of the answer around the maturity curve. I think a lot of folks early on, if you talk to people that are just trying to build any piece of software, forget generative AI, the first question is just, if we're going to prototype something, like, does it work? And at that point, most people, if you don't have an ML or data science background at some maturity level, you're not thinking about things like evaluations. Very few people start building a new web app and begin making sure it all runs smoothly with CI, right? The same kind of mindset. That stuff comes later. And I just put this together. I talked to me the other day, they built a new prototype. They let Claude Code build all the prompts. They weren't paying any attention. They just wanted to know, does it work? They do some of that testing. That's very vibes based. put it in front of some customers. Now the question is, does anybody care? Is anybody going to use this software? They're still in a vibe mode a lot of times where maybe they'll tweak some things. Their testing process tends to be manual at that stage. They're trying to incorporate customer feedback and see if anybody really wants to use a piece of software. And then you get past that. The next question, I think, where a lot of these prototype to production projects stall out is if somebody does care, can we trust it? Can we actually ship it and put it in front of customers at scale? What happens then is often all over the place and can even depend on the organization. We see a lot of places where that conversation dies with legal or the security team. Maybe at that stage, if they're starting to really make progress, that's when we often see teams that have never done generative AI before start to think about evals because they're realizing all the manual test cases that they're managing are now ballooning and they're finding edge cases and they're chasing down regressions and saying, we wish we had a way we could do some of this faster, not have to test everything one row at a time. They start to think about what can we do with automated evaluations specific to our product context, right? We're not talking about MMLU. We're not talking about these public benchmarks. We're talking about I'm building software to help generate an insurance risk report, all kinds of dimensions on which I could decide if that's good or not. I'm trying to figure out, is this match human expectations for what good looks like? Once people make it to production, I think that's where they're often, maybe in the past 3 years, 1 in 5 teams, 1 in 10 teams. We hear a lot of these, especially in the larger the company, the more of these projects have died pre-production. You get there, and that's when people start to think about, okay, we were testing with a few hundred examples offline. Now we have a few million from what customers are doing or what's happening in some system at scale. We got to figure out what online evaluation means. How do we build custom analytics for the LLM era on our production logs? Because Datadog will tell us that we're getting a bunch of 200 responses, but it's not telling us if this content's any good and what are people doing that's weird with it, right? So I think that's kind of the curve we see people go to. And a lot of teams, like we run our own podcast, Deployed podcast, or some multiple people that have been on it say the same thing. One of the most common bits of advice we hear from people that have made it to scale is we wished we'd started working on evaluation earlier. And at the far extreme of that, the most mature teams, you talk to folks at Google or at OpenAI, like start with your evals. The most mature teams have learned you begin by defining what the shape of this system should look like. What are the failure scenarios? What's a positive case look like? Define that up front. And then you're basically doing all your prompt engineering and agent orchestration, like hill climbing toward that metric. I think that's what the scale point looks like when people are doing it great. They've figured that out. They built a system that allows them to quickly detect errors, iterate on the system, test it in an automated CI/CD way or production A/B test, and have confidence from metrics that they're in the right direction. I guess maybe the last thought is that every single one of those teams invests a ton in human review. I don't know any of them that have replaced looking at lots of row level data with some metrics-based eval panel. The evals are instrumentation to point in the right direction, but quality still is coming from people paying attention to the nuance of what's happening and figuring out how to make it better as a result. So that's kind of the progression from can we make it work to can we trust it to now that it's live, can we really make it better and eventually make it great? And to do that, you need more and more mature systems.
I think that's a very good overview, Ian, because there's a ton I want to unpack there. Because you said a few key terms and phrases. One thing that got me thinking was when you said what good looks like, because I think there is a lack of consensus of what good means, right? Who gets to determine what good means? It's not simple, straightforward evaluation techniques.
Yeah.
That's kind of interesting. And then you talked about offline testing and online testing and for offline, that's basically test your model or agent or prompt, whatever it is, before it gets in front of users, of course, before it gets in production. And online is you're doing that evaluation. If we could talk, and you also mentioned human in the loop there, but now we have reinforced learning with AI feedback. Before we get into all that, let's stick with offline versus online evaluations, which is a key area for a lot of people to understand. I believe, and I think a lot of people share this opinion, evaluation remains one of the hardest problems in large language model development. Everyone likes to beat up the benchmarks. They are saturated. New ones are coming out. But that aside, and look, with MCP now, we've got tool usage is proliferating. I was just looking at, there's, I think, 8,000 MCP servers listed on there right now. Memory architecture has gotten very complicated. How do you evaluate planning? So how do you think about balancing the offline evaluation methods like test sets, LM as a judge, with some online evaluation techniques such as A/B testing and then maybe tracing
Yeah.
and debugging, telemetry, user feedback, we just mentioned. I know that's a very big question. Sorry.
Yeah. Going back to one of the first things you said, which was just like, what's good look like and who decides? I think it's important to start with my perspective. And as I answer these questions, where are we coming from? I think a lot of your audience, data science, ML community, that answer might start with what are the latest techniques? What's the research trajectory looking like? What are the more advanced ways we can solve these problems? Are we adopting those? Is that some version of best practices from research or frontier techniques? We spend our time mostly with mid-sized to large enterprises up to Fortune 100 companies that have been running businesses, generating millions, hundreds, billions of dollars a year, bringing generative AI into their products that are customer facing, where revenue matters, quality matters. A lot of that perspective leads to a very pragmatic view on things. So when you say, what does good look like? When I answer that question, I'm answering it in terms of a production team that's running a voice agent at scale or some kind of tool calling agent at scale. Can you know how it's doing in production relative to some true north business metric or customer perspective? If it's failing on any dimension, can you detect that? Can you fix it if you detect it? And can you do that quickly without having to do a bunch of random turning of knobs and hoping things get better? So when I think about that good answer and thinking about, can you run that loop and build reliable, high quality software that your customers want to use and that they don't just say, meh, it's not that compelling, not going to use that AI feature again, or this is really bad, but it's just blatantly wrong. Does that help anchor a little bit?
Yeah, absolutely.
In light of that, that's my answer too on online versus offline eval. Like you mentioned benchmarks getting saturated, right? None of our customers are thinking about benchmarks. They're deferring all that to the model providers. Thank you, OpenAI and Anthropic and Gemini and Llama and everybody else that's training models, Mistral, for doing the hard work. Now there's these magical REST APIs. Like you don't have to have a big in-house team of ML researchers to come up with a high quality product, right? You know, if you start there, they're looking at like those folks are figuring out how they do on the benchmarks. The product builders are trying to figure out, is the format coming back from the model correct? I think we're increasingly past like lots of hallucination, but it still happens. Is the answer that's coming back complete relative to what a human expert would have wanted, or does it capture the nuance that we'd want? If you're doing any kind of categorization work, like simple questions, does this just match with our ground truth data set, or is there appropriate semantic similarity? Like those are the kinds of evals people are running in our world. And they're often running 10, 20, 30 per prompt. And then as you build up increasingly complex agentic systems running agent level evals too, lots of folks are looking at, to your point, are there appropriate tools being called? Are we disambiguating the model level? Are we disambiguating tool calls appropriately and finding our way through an agent system in the right way? And if we're not, can we feedback into the product and improve that? That's the space that I'm talking about with product evals versus the foundation model benchmark evals.
I think it's very interesting because what you just mentioned brings to mind the AI maturity curve, as you talked about. Thinking about that AI product development, what you described is almost a path from exploring prototypes to getting it production. But what do you think are some of the key turning points for teams and where are they getting stuck?
I think a really common pattern, and people might be surprised or might, with some very large companies, household names that you'd see doing presentations about their AI roadmap. When they first call us, their engineering leaders, product leaders are saying, we're finally ready to get serious about evals. Tell me more. And they basically say, we don't know what's going wrong in production. We've shipped this stuff, but we find out when our customers complain. We capture a bunch of logs, but we don't have a good way to look at them and make sense of them. Our iteration process involves human experts spending a lot of time just reading through row level responses and trying to decide if they're right. We've been hearing about evals for a long time and we need to get serious about them now. I think at this point in summer 2025, for all the chatter on Twitter and other channels in the generative AI developer community about evals, a lot of groups that are working at scale still aren't really using them. I think that path often looks like, hey, we want to get in control of this system and stop having to do all the testing and iteration manually. We want the freedom to try a new state-of-the-art model. We feel pinned to the old one because we tested so heavily around it that we don't really feel confident to try anything new because we know even if we take the same set of prompts, they won't behave the same way. So we're kind of stuck. They're saying, hey, we're getting a lot of complaints on this dimension. We're just iterating, trying to fix them, but not really moving the needle. So I think that's a place where I find a lot of people are saying, okay, great. We've learned the hard way. We need to build some like kind of plastic systems engineering level stuff that let us automate more of this process. And, I think one of the first things that people are trying to figure out at that point is that you've been doing some manual offline testing. It's common that people at that stage have a process they work through test cases, but they just don't really know what's happening at scale, whether they're producing hundreds of thousands or tens of millions of interactions. They're trying to figure out like what's actually going on in production. How do we like categorize this stuff? Classic axial coding exercises, like what are the most common sets of errors and how do we tackle those and try to fix them? I think that comes back to what you mentioned before about online versus offline eval. In our world, there's like our mindset, kind of two modes of online eval. There's the true guardrail mode, right? Can I detect that a potential response from a model is not what I want it to be before I ship it out to a customer and do some kind of self-improvement loop so that we only send something good out the door? That's very different from a more metric-oriented mindset like I was describing. Can we actually understand behavior at scale in production and identify the issues we want to fix? A big part of what we see folks start to do at those moments is define those product-specific evals that they want to run over production logs as they come in and treat it like they've built their own custom analytics. That really becomes the key to unlock what are the problems we need to solve? What does the row level data look like? What are the examples of those failures so we can go work on improving them? Does that resonate with what you've seen?
Yeah, absolutely. It makes a ton of sense because at the end of the day, there's just so many levers to pull, right? Tuning levers, prompt tweaks, model choices, as you mentioned.
You got to do is know what you got to tweak.
Exactly. No, I like that. And a lot of people are talking about model routing and tool routing, which is another layer of complexity. And as we were talking earlier, it's so easy to test the wrong thing or over-focus on the wrong thing or over-optimize in, because a lot of what you're saying here makes a ton of sense. Improving an AI system can mean, and we hear this advice all the time, tune the prompt, swap the model, evaluate a new model, and you just hit the nail on the head. The company's coming to you and says, look, we spent all this time evaluating and seeing if we can trust this model. We know there's a more performant model out there, but we're not sure if we should move to that. Fine-tuning is still a thing. Reinforced fine-tuning is a new thing. They vary wildly in effort and risk and most certainly payoff. I think it's a very tricky landscape out there. You've described a lot of this already, but just to tie it all up, how do you optimize, focus on prompt engineering versus swapping a model, or do you go deeper? Everyone's rushing to reinforce fine-tuning now.
Yeah. So basically, it's like there's a whole set of tactics people are hearing about that have some appeal, right? They promise a way to improve an AI system on some dimension. Which one do you try? When is it worth it? I'll share some things from experience, but I think one of them is that I think a lot of teams have learned this now, but if they haven't, like, good word of advice, you don't want to spend any time on fine tuning until you have the system working right and have some scale of data to work with. So I think that's one of the things we see early on. People get tempted by all the buzzwords. Just pick a state-of-the-art model, prompt engineer it, orchestrate the basic agent system, see if you can get it to work with all. Fine-tuning becomes a big exercise where you need to curate the data and have some sense of the shape of the data, what it needs to look like before you go down that path. Like, you need to first get to like knowing the system can produce that shape of data. Fine-tuning is an optimization, right? That's one of the things I think that folks in our world that we work with that are getting a lot of leverage out of fine-tuning have real scale of data and a relatively like baked use case. Like, they know what they want the model or the agent to do. You mentioned some things around new techniques, reinforcement, fine-tuning, really promising because it has a need for less data and can get you to a more efficient inference profile faster. But still, you've got to know this is what we want to do. You mentioned a bunch of RAG optimization things. I think when you get this world, like, are we spending time on prompt optimization or model selection or whatever else? We have a whole class of customers building RAG systems where they'll tell you the prompt engineering pieces aren't really the problem. Their challenge is how do we get the right context into the system? So I think if that's your problem, we come back to what I said before, first you want to be able to identify and know what are the problems in the system and then prioritize fixing them. There's lots of folks trying to get into how do we tweak the retrieval aspect of our system? Do we even have the right source data in our corpus? It's hard to know that if you're doing basic semantic similarity retrieval techniques, because you end up wondering what else might be brought back. So we've seen a lot of teams spend tons of time tuning the RAG aspects of their system. I think the most important advice I'd give is like, set the buzzwords aside, get really clear. What are you trying to make happen? What stage in that maturity process are you in? And then look at the set of tactics, best practices, research that are specific to that area. If you know you've got the right content coming into the system from the context standpoint, or that like, this isn't a RAG system at all, we're just trying to shape a prompt to produce a high quality summary based on some definition, medical transcript notes. You can focus on prompt engineering and model selection in those scenarios. So I think it just goes different directions.
Spot on. Yeah, definitely. We could spend a whole podcast talking about a RAG evaluation itself. That's something we grapple with a lot. It's just finding, as you mentioned, the context relevancy around documents and then making sure we have that recall, because that's a question I get every week.
It's like worth telling a story. One of our customers has talked publicly about this, so I feel I can share this one openly, but the team at Postscript were working on an agent that is, Postscript helps Shopify merchants communicate with their customers through text messaging. They were trying to figure out like, how do we build this kind of personal e-commerce, marketing assistant, or not assistant, but like agent that would like communicate with the customer and ultimately goal to get them to buy. But they've got thousands of merchants, all kinds of different goals, types of businesses, discount codes, like all sorts of things that they're working through. They had a really promising candidate in beta, and they were trying to figure out like, how did we get this live with confidence at that scale? This is not a human in the loop system. Text messages going out have to be right. If you listen to Evan from their team, who was on the e-commerce side, not the engineering side, how did they get there? Like just methodically reviewing data from the system, figuring out types and categories of failures. For instance, like this discount code was hallucinated. How do we make sure that the model is, because we know these models are really bad at strings of random tokens, right? Or random characters, they'll replicate different things. That becomes a class of problem to fix. They'd write an eval around, be able to do batch testing, offline experimentation over an iteration in the system that's trying to fix it. Their evals, whether those are like some kind of custom code function or an LLM judge, or helping catch like, well, is this class of failure happening? Is that class of failure happening? This brand has this tone they want to use. This other brand has this other tone they want to use. Are we matching the brand voice? Are we saying the right things to the right customer? And that was just like doing that loop over and over again of see what the system's doing, clustering the problems, running experiments to fix the problems, pushing it all live, and then seeing what's the new problem now, and just kind of hill climbing toward a high quality, trustworthy customer experience.
That's a great example. And moving into agentic AI evaluations now, as these agents grow more complex, tooling is exploding. Agent planning, as mentioned, memory architecture there is getting very interesting, very powerful, but also a lot of complexity there. And when I think in terms of how we would evaluate those agentic workflows, we're still struggling with observability across those intermediate steps, right? Because you did mention human evaluation at the start, and you find that human evaluation is expensive, it's noisy, but I talked to a few teams that are using very expensive domain experts to review this stuff. And I do think when I look at the labeling, I think for the most part, that requires its own evaluation, because some of it can look subjective.
Yeah, we've had this debate internally. Like we've got several examples where people can't really get their LLM judge trustworthiness above 70% or so. And they also can't get their human judge rater agreement above 70%. So maybe neither one are that reliable. I think that's one of the challenges here. Some of this stuff gets subjective.
Yeah. Where do you see this end-to-end agent evaluations and observability going through 2025 and the rest of this year?
Yeah. It's like the further out's harder to think about, but I think that's a good time horizon. I was just talking to somebody yesterday, VP of product, big company, like S&P 500 scale, and they're struggling with this problem, but I actually don't think that they are, because what they're doing is status quo with almost every team we talk to, which is the LLM judges using aren't perfect, and they're sometimes not that insightful. And I think a lot of people have hoped that they've been able to instrument this fully automated system that produces trustworthy metrics. And if you just tune the metrics, you're up and to the right. But then when you have informed human experts look at what the system's doing, there are times when the metrics are all green and the outputs are just not that great, especially if they're subjective. It's very different if you're doing a data categorization exercise. Like that's objective, sometimes with code too, right? But these more subjective use cases, he was wrestling with this, and the highest leverage thing we've figured out how to do is to have a few people spend a couple hours every 2 weeks jamming through some random production logs to see what the system's doing, recognizing like they're functionally computers. They're bringing into the system more than just these rigorous defined criteria. They're bringing taste. They're bringing nuance that previous engineers in the system writing these evals haven't had the time or yet articulated, like, oh, what's that thing you're evaluating for? And like that back and forth of having human eyes on the data and then instrumenting what you can to automate error detection and other things in the future is the status quo. I don't know if that's a bad thing. I think the challenge is for teams, like how do you instrument enough to scale and keep the human expert work focused enough that it's not overwhelming your organization? We can point to Hamal Hussein, Shreya Shankar, and their evals course. Multiple of our podcast guests talk about this. Like the breakthrough in quality that so many teams have experienced has come from people just getting close to the data, sometimes thousands of rows. You also asked about agent evals. We've been talking about this, a lot of people. I think there's all sorts of trails you can go down. You mentioned memory evals. Maybe put that in the category of something like RAG systems. It's a defined space. It's going to need its own set of solutions. But just like the basics of like multi-step tool calling agents, when we think about it, we think about kind of building blocks in a classic systems engineering sense. You want to be able to have prompt and tool level individual unit quality, and then build a system that looks at end-to-end behavior, both the flow through the system I mentioned before. It's this step in the agent making the right tool selection, and then also looking, given a task, was the task completed at a quality bar that we'd expect? And so like, that's the way we see people instrumenting agentic eval systems is like, can we have good, like unit test level eval coverage for our units in the process with prompt behavior? And then can we build out a way to evaluate end-to-end behavior for making the right decisions on the path? And is the output of the whole system aligned to what we would expect? So you're basically just building this multi-layer eval structure. Oftentimes a lot of the same tactics along the way, custom functions, building the ground truth around the agent output, evaluating similarity, looking for various types of failure criteria. What you end up wanting to do is layer the evals into your system and be able to look at each layer and automate as much of that testing and error detection as you can.
Oh, nice. And do you find at the end of the day, a lot of traditional engineering, software engineering can help out here as well? I talked to another team that was doing something similar. They were looking to get more observability into their agents. They were trying some A/B testing, and then they were working in these human loops. But the last part, they were looking at a lot of auto logging, and they pointed me to an open source project called Open Telemetry. The whole idea here was debugging and logs and making sure as you're calling different agents, not only outputting the logs on that and looking at things like latency, any failure points, trying to log the A/B testing feedback. And it's not just about failure, but the token usage has exploded with some of these models.
Yeah. If you have an autonomous agent that does some kind of loop, some people just don't know what they're spending.
Exactly. Until the end of the month and they get their bill and they're like, holy crap. So that's interesting. And then they're using that data to kind of prompt tune or do other aspects.
Yeah.
I know your company does work around voice and voice agents.
Yeah.
And I see from your website, you've done work with Pipecat, which for our users who haven't checked it out, pretty cool platform for using voice. Yeah.
It's a great open source orchestration platform. If you're doing all the voice stuff, it helps with a lot of the hard pieces of voice.
Yeah. And I got to say, for the most part now, I use Siri, really waiting for that OS grade that I bought my iPhone 16 for.
We're all waiting Siri's along.
Yeah. But voice is how I want to interact with my computer. I've been coding for years. I've typed enough keystrokes to last me a lifetime. So I am very excited about voice. You work with Pipecat and voice integration. I think it's an exciting new frontier. Conversational agents and how they work with memory, context, speech. I think they're going to add major layers to the user experience and a lot to evaluation complexities. What are you learning from building and evaluating voice-based agents, and what makes them, I guess, uniquely hard to test?
Voice is really cool, right? Like voice is a natural format for people to interact with an AI. I had my first call the other day where I had an inbound call. I had ordered checks, and the person that called me to verify that I'd submitted all the right information and ask a bunch of qualifying questions about what type of check I wanted. It was a voice AI. Never experienced that before. It sounded really real, but it had these little tells where it kept saying, okay, when it said that there was this little click in the audio. Other than that, the conversation was natural. None of it felt scripted. It was like the latency was like short enough to like cross the uncanny valley, right? Like it wasn't weird. So I don't know who was behind it. It was like, okay, this is working. I talk to advanced voice mode from OpenAI all the time in the car. It's great. And so I think people that are building these systems, people building them for customer service, user research, scheduling, and call processing, these are the first use cases that are really taking off. It's a lot of the same problems, right? Where you need to know, are the prompts behaving on whatever criteria we care about? If it's a RAG system, is it accurate? All sorts of different ways to evaluate whether you're saying what you want to say or covering the right parts of the script. All that stuff can happen on a transcript. And I think that summer 2025, best practice is definitely to do that on a text transcript. But kind of a foundation for like, okay, is this thing behaving the right way? The unique parts of voice become some of those things I mentioned. Is the latency believable? Quinn from Pipecat mentions this on our podcast. It's like 800 milliseconds is his bar these days, much higher than that. You're not going to be believable. You need to keep an eye on that. One of the big challenges everybody's facing and the Pipecat team have tried to tackle with their open source model is turn detection. That's one of the things that like you talk about what's hard for the people that are just doing text level transcript analysis for their eval. The transcript ends up looking reasonable to a human.
When you say maybe turn detection, what do you mean by that?
So what you and I are doing right here. If I'm talking, does the AI interrupt me at the wrong time? Or if I stop talking, does the AI pick up at the wrong? Are we transitioning back and forth in the conversation in a natural way? That's the kind of thing where it can feel very awkward at a user experience level if you don't get it right. It doesn't necessarily make itself apparent in a transcript. You can maybe detect there's some confusion or awkwardness happening between the assistant and the user. How do you make that better? So I think probably the state of the art, again, like this point in 2025, is people are doing a lot of simulation testing, like with a human interacting with the system to dial in the voice elements enough and know, okay, that was wrong. So I think what we see our customers doing is a bunch of that offline testing. And then if they have permission, if you're doing B2B software and you've got the permission, your contracts with your customers or whatever, to actually capture the voice recording, they then are logging that and saving it as part of observability. And when they get back into like, okay, there's a low customer feedback score, a big thumbs down or a low NPS, or otherwise that automated eval detected the user is dissatisfied, be able to listen to that call recording and be like, oh, okay, here's the issue. That's just awkward turn detection, or we were mismanaging some part of the voice. But we haven't really seen people figure out a clean, repeatable, easily replicable playbook to automate some of that stuff outside of some amount of human in the loop simulation. I think that's okay. People are shipping at some scale where that's the case. I think there's a bunch of opportunity to automate that more for folks in the same space of like, if you want to optimize a memory system, you want to optimize a RAG system, there will be solutions that come along just for optimizing a voice system. Like this point in 2025, have some good text evals, do good simulations, and be able to tune the system when things aren't working well. That's an important part of what Pipecat and other frameworks like it help solve for too.
Excellent. Very exciting space. I'm using a few other products like that as well. Yeah, they work very well one-on-one, but I can see that turn problem being real. So to wrap this up, I got a few final questions. Just wanted to come back full circle. We talked about the maturity curve for companies. You want to build this culture around evaluation, focused development. What roles are critical? Because again, I've been focusing a lot on this notion of an AI evaluation engineer for one particular piece of that. So how should people think about this?
That's interesting. What's an AI evaluation engineer when you define that?
So when I define that, it's what we always used to say in the traditional sense of software engineering. We would never have the software engineer test their own code because they never want to kill their own baby. If you're a software engineer, you wrote this beautiful set of code, you hand it over to a QA engineer who's an independent reviewer of that. So In my book, an evaluation engineer would start with the evaluation criteria. So an engineer builds the workflow, and now we're going to have someone come and evaluate it. Because I find a lot of times teams are relying on the same people who built it to evaluate it, which we've known throughout the history of engineering, computer science. Having the builder and the tester be the same people is always prone to issues. So to me, first and foremost, it's a separation of responsibilities. Who's going to be the final arbitrator saying this meets our evaluation criteria?
Yeah, that's an interesting way to frame it. I think we probably see it similarly. Maybe there's a question mark around whether that person doing the evaluation always should be or needs to be an engineer. Right? We have our old roles with more traditional software engineering, design, product management, and data science or ML. Those are people's titles today. In the new world, building these generative AI systems, you have different functional responsibilities that need to be fulfilled. A lot of folks are working through who fulfills them. And that can look different based on the org, the culture, the type of product that you're building. You were saying there's the systems engineering need to make sure this pipeline runs reliably, orchestrated well, does the right things. If it's not doing the right things, do you know how to fix it? Do you know how to detect it? There's still a role for software engineering here. Then you get into these other responsibilities. There's a whole space around prompt engineering and tactics that can be filled by an engineer, can be filled by somebody outside of engineering, but kind of like you were getting at, on the one hand, you want somebody else to do the QA and make sure that it's right, but you also need somebody doing that initial work in cases like vertical SaaS or like healthcare or something with AI. You need somebody doing that initial prompt engineering that knows what the outcome should look like, right? And that might not always be an engineer. So I think we see a lot of folks where there are people that really have a good grasp on that domain or the customer experience you want to create. Sometimes they're product designers that are like learning prompt engineering tactics. And then you get to evals, kind of similar, right? Evals in this space don't have to be that complicated. You can write an LLM judge to detect whether something is happening, or a relatively simple Python function to make sure things are formatted correctly. A lot of folks rely on regex. That doesn't have to be a mature engineering team. It can sometimes be a misfit with traditional ML folks that have been doing like NLP evals or evals on predictive systems for a long time, especially if what you're working on is a relatively subjective output.
Exactly.
Multivariate success criteria, right? And so people come in trying to apply traditional ML metrics, Rouge or Blue or whatever else, will come in wanting to know, well, we need to really calculate an F1 score. You're like, what's the F1 score for a summary product, right?
Exactly.
Got a lot of potential success outcomes. So I think what we've seen is when you get to doing the prompt engineering, doing the eval definition, like doing quality, even if that's human review, but this, kind of quality role generally, like whoever's doing it has to have some domain understanding in most cases. I think where that gets different is if you're doing big consumer software or something relatively generic, like document work in the product like Notion, where there's less domain specific stuff to figure out. Those teams we see be more successful, engineering and ML running the show, because it becomes much more statistical to figure out if you're on the right path in those cases. And the more you get into niche subjective spaces, the more you really benefit from a domain expert in the loop. But yeah, you take those traditional software jobs and map them to all those new responsibilities. I don't know if any organization is mapping them in quite the same way. The big successes involve a domain expert if you can. Look at lots of data, write some evals, figure out who's your best people to take that on.
Yeah, I think a lot of emerging roles there. It's going to be very, very interesting to see that. But Ian, I've taken a lot of your time. So final question here. I know that you guys do a lot of work in the community. You have meetups, you have your podcast, you got a great blog site. How can people get involved in your community? Tell us about that and follow the great work you guys are doing there.
No, that's awesome. We spend a lot of time investing in content in this space, trying to help other builders. Our podcast is called Deployed, the AI product podcast. We have people come on the show that have been running product or engineering teams at scale, shipping generative AI systems, talk about lessons learned. So I think a lot of people can learn from other builders there. We've done these in New York, San Francisco, Austin, LA. We do a meetup series and a dinner series for leaders in this space. And a good way to plug into that is to keep track of us on LinkedIn, or there's a newsletter at olderaibuilders.org. And then our blog is probably the last thing, just freeplay.ai/blog. We produce lots of long form content, how-to guides, case studies, lessons learned, people building in this space. So those are all resources people can check out. If you're interested to talk more, love to chat. But yeah, thanks so much, Seamus, for the time. Thanks for having me on.
No, thanks, Ian. This has been an education. And I think, let me know if you're having a meetup in Colorado this winter, because I love going out there to ski. We just need an excuse to learn something and do a little skiing. I will include a link to all those in the show notes so people can check out the podcast, your blog, the meetups as well. So I will look for those and add them to the show notes. And Ian, this has been a pleasure. Thanks for some great explanations around this space. It's fast evolving. So I would advise people to subscribe to your newsletter, check out the blog and the podcast. Some pretty impressive guests. There's so much great content you guys have been generating. And thanks for doing all that work for the community.
Thanks, Seamus. You too. Appreciate you having me on.
We'll chat to you again.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.